What is happening, mathletes? Last assignment of the school year, of the crazy fourth quarter quarantine, COVID mess that we're in. This is it. I know you guys are excited because I'm excited. Eighth graders, moving on. Almost in high school now. That's pretty cool. All right, before we get to our last lesson, just a reminder that all schoolwork is due Friday, June 12th. You can drop off on June 12th. You can make sure everything online is submitted, if, whichever one you're doing. And yeah, we're wrapping up here. This is awesome. Today's lesson is learning how to find the vertex of a parabola. And I'm going to move this camera around here so we can get to, I'm only going one camera today, one angle. So excuse me for just a second while I get this rocking and rolling. All right. Hello in the chat there. Finding the vertex of a parabola. So let's first talk terms. Vertex of a parabola is the maximum or minimum point of a parabola. So minimum point being the lowest, maximum point being the highest point, lowest and highest, minimum or maximum. So that's the vertex. The vertex, remember, parabolas are symmetrical. So the vertex runs through the line, what's called the line of symmetry, right? It's the line that cuts the parabola right in half. It's a little blurry. I'm sorry about that. See if we can get it to adjust. Yeah. Anyway. All right. Last week's lesson was learning how to use the quadratic formula to find our x-intercepts. And oddly enough, we're going to come back to this because this actually plays a role and it helps explain what the quadratic formula is actually representing. Because it's a pretty lengthy formula, but the parts to it actually make a lot of sense. Let me scroll down here. So, to find the line of symmetry, that line that cuts parabolas in half, it's actually this little tiny formula here, negative b divided by 2a. And remember, a, b, and c are the a, b, and c from a standard form quadratic equation. So where we get our a, where we get our b, and then change the symbol for it. So negative b just means change the symbol of whatever b is. If it's positive, it goes negative. If it's negative, it goes positive. And then 2 times a, divided by 2 times a. So we're not even using part C to find the line of symmetry. This line of symmetry actually tells us the x-coordinate of the vertex. Because when we calculate this, that tells us, where on the x-axis does this parabola get cut in half? Left or right, how far is the line of symmetry? Line of symmetry for parabolas are always vertical lines. So if we look at an example, oh man, let me, well, you know what? We'll just use problem 1 from last week's quadratic equations. That'll be our example this week. I'm going to write this down over here. Example number 1, or just problem number 1. M squared minus 5m minus 14 equals 0. Okay, so to find the line of symmetry, or where that line that cuts the parabola in half, we're going to let a, in this case, equals 1, and b equals negative 5. So when I go to find my line of symmetry, negative b over 2a that turns into negative what b is divided by 2 times a. Wish I could zoom that in a little bit, but I cannot. Now, if you simplify, negative, negative, turns positive. 5 halves is 2.5. So that means, if we were to go and graph this, 1, 2, 3, at 2.5, that's where this parabola is getting cut in half. So the x-coordinate of my vertex is going to be at 2.5. Oops, shouldn't have put a parenthesis around that. 2.5, comma. Now, the y-coordinate, so if we know we have to come over 2.5, now are we going to go up or are we going to go down from there? Man, I wish this would focus up. Okay, what we're going to have to do then is find out what y equals when x is 2.5. So that means plug in 2.5 back into your original equation. Okay, and I'm going to actually turn the page for this because I need a little bit more room to write. And I'll rewrite what work we've done so far. But for m squared minus 5m minus 14, now we're going to figure out what that equals for y. So this, we're solving for the x-coordinate, which is represented by the variable m for this problem. But since we know that m, or the line of symmetry, is at 2.5, we plug in 2.5. 2.5 squared minus 5 times 2.5 minus 14. That will tell us what y equals. So I'm going to need to calculate this using my calculator. So 2.5 squared is 6.25. And then 2.5 times 5 equals 12.5. And so we go 6.25 minus 12.5 minus 14. And we get y is equal to a negative 20.25. So the vertex for this equation's parabola is at 2.5 comma negative 20.25. All right, now this is a critical point on a parabola, especially if we're graphing. Now we don't have to estimate where it is. We know. And I'll kind of make my graph to scale here. 1, 2, 3. So 2.5 is our line of symmetry. And if we go 5, 10, 15, 20, it's going to be right there. Our vertex is right there. Now, combine in with what else we know. M is positive, or A is positive, so it's opening upward. We know that the y-intercept is at negative 14. Right there. So if we go over to 5, that's going to mirror. Okay. And then, since this is problem number 1 from the quadratic assignment number 1, you you should have the x-intercepts already for number 1. If you still have that assignment, you should. I hope you do, or at least a picture or copy of it. So now you can actually write down the x-intercepts too. So now we have a vertex, a y-intercept, and from last week you have already found the x-intercepts. So that's where this comes from, and I wanted to make this point about the quadratic equation. Let me use a different color because it's a different point. When I realized this, all of a sudden the quadratic equation made a whole lot more sense to me. Okay? If you notice right here, here's that negative b over 2a. Negative b over 2a represents our line of symmetry. Okay, that's how you find the line of symmetry, the line, that invisible line that cuts the parabola in half and whose x-coordinate is our vertex. All right? So if we go to our line of symmetry and then we do the plus or minus part here, it's actually called the discriminant. If we do the plus or minus, that means from our line of symmetry, if we go to the right a certain amount and minus, or to the left a certain amount, we'll find our x-intercepts, right? So line of symmetry gets you to the middle, the midline of the parabola, and then we do the plus and minus to see how far left and right we need to go from here to find our intercepts. And again, once I made that realization that this formula is actually very directional and makes a whole lot of common sense, now using it makes it a lot more personal. And it really brought it home for me. And hopefully that's the case for you as well. So we would use this to figure out our x-intercepts, remember, by finding the midline and then going left and going right a certain amount, the plus or minus, to find where exactly the intercepts are. Now, if we have this goes on for other problems, but you can have parabolas that only intersect once, right? They only have one intercept. The vertex is actually on the x-axis. Well, still, you would, and this is, I apologize, this is kind of bleeding back into using the quadratic formula a little bit, but it all goes together pretty tightly. So when all of this, when b squared minus 4ac equals 0, when this section equals 0, that's when you're going to get one intercept, because we're going to go to the line of symmetry and then we're not going to go anywhere. We're going to go plus or minus nothing, because if the b squared minus 4ac equals 0, that just means it's touching the x-axis right here once. That's it. We don't have to go left or right any to figure out what two intercepts are. There's only one. And as a side note, and we didn't have an example of this, but when the square root of b squared minus 4ac is a negative, if that ends up equaling a negative number, then that means there are no x-intercepts, because you can't square root a negative number. All right? So we can still find a line of symmetry. We can still find that invisible halfway line, but as far as x-intercepts go, there aren't going to be any. It's either going to, it's not going to cross the x-axis at all. So it's either going to open downward below it or open upward above it. So anyway, I'm sorry for the sideways rabbit trail here, but the goal really today is to find the line of symmetry and use the line of symmetry to find the vertex. So let me wrap this up by saying, to find vertex, and this is maybe what you want to write down. Step 1, line of symmetry for x coordinate. Okay, that's the negative b over 2a. That'll tell you your x coordinate of the vertex. Now you still need a y coordinate to finish it off. So step 2, plug in your x value that we just found right here into original equation. And solve. Whatever you get when you plug in, like up here, when we found that the x line of symmetry was at 2.5, we plugged in 2.5 and then solved for y. Okay, and that'll tell you your y coordinate. All right, and remember, your answer for a vertex is a point. Okay, the vertex is a point. And I wish this would focus up. All right. So, if you have last week's 8 questions that you were to have done the quadratic formula for, apologize. I'm just looking here. My handwriting is not ideal. Oh, it focused up for just a second. Anyway, I guess you can pause on that if you want to write it down real quick. Because I'm only using the same problems from last week. Okay? And here's the assignment. It's the same 8 questions from last week where you found the x-intercepts by using the quadratic formula. But this week, I want you to find the vertex for the 8. So find the line of symmetry and then plug that in for the variable. You should have these already, or hopefully you saved them. And then the y-intercept is just c. Be careful for the last 2 problems what c is. All right? That will give us a pretty accurate description of what the graph is, and I want you to sketch it. All right? Knowing the vertex, the x-intercept or intercepts, and the y-intercept gives us a very good idea of what this parabola should look like. And remember, it's symmetric, so whatever happens on one side of that invisible line is being mirrored on the other side. Okay? So vertex is new. That's this week's. X-intercepts, what you should have done last week for these 8 problems, that's quadratic formula. Y-intercept, that was from like 3 weeks ago. It's what C is. It's very simple to do. Look back or ask a question if you can't remember. And then take those, at the most, it's going to be 4 points. 1, 2, 3, 4. You're going to graph these 4 points, or you're going to sketch the graph of these 4 points on a piece of paper, and there you go. That's the last part. If there's only one x-intercept, then there will only be 3 points to graph, which I think will happen on one of these. I think one of these only has one x-intercept. All right, folks. Good luck to you. Make sure you turn in everything by the 12th, June 12th, by Friday. Either drop it off on Friday or have it submitted online by Friday, because then that gives me enough time to have all grades done by the 19th, which is technically the last day of school. And I know you guys are doing a little bit of an all-school activity for the last week, so this is it. But you guys, high schoolers now, congratulations. It's been a pleasure teaching you guys this year. I really appreciate the hard work that you've put in and the efforts despite fourth quarter being really weird. Keep an eye out for the 8th grade awards assembly, which will be put out online, I believe, or as part of a presentation that 8th graders, it's for you guys. I think the whole school will be able to see it, but It's only 8th grade awards. It's not 7th or 6th grade. We're going to be giving out some math awards for 8th graders, Mrs. Eldred and I. But I put it in a little bit of a presentation that when you see it, I think you'll understand, oh, Mr. Lemiere did that. Anyway, let me know if you have any questions. Email or submit them to me through Google Classroom. Otherwise, get this stuff in by Friday and you're done. Algebra 1 over. All right, guys, I'm ending broadcast. Hope to see you soon. Pop in, say hi when things get back to normal, and let me know how high school goes for you. Otherwise, I'm out.